8871. Compared to normally aspirated engines, turbocharged engine exhaust systems operate at A. Similar temperatures and higher pressure. B. Higher temperature and higher pressures. C. Similar temperatures and pressures. The correct answer is B. Compared to normally aspirated engines, turbocharged engine exhaust systems operate at higher temperature and higher pressures. Turbocharged engines use a turbocharger to compress the incoming air, resulting in increased air density and higher pressure in the combustion chamber. The turbocharger is driven by the exhaust gases, which exit the engine at higher temperatures and pressures than in normally aspirated engines. This higher temperature and pressure exhaust gas is then used to drive the turbocharger, providing a boost in air intake and improving engine performance. 8872. Most exhaust system failures result from thermal fatigue, cracking in the areas of stress concentration. This condition is usually caused by A. The drastic temperature change which is encountered at altitude. B. Improper welding techniques during manufacture. C. The high temperatures at which the exhaust system operates. The correct answer is C. Most exhaust system failures result from thermal fatigue, cracking in the areas of stress concentration, and this condition is usually caused by the high temperatures at which the exhaust system operates. The exhaust system of an engine is exposed to extremely high temperatures due to the combustion process. These high temperatures, combined with the cyclic heating and cooling of the exhaust components, can lead to thermal fatigue. Areas of stress concentration, such as welds or bends in the exhaust system, are particularly vulnerable to thermal fatigue cracking. Proper design, material selection, and maintenance are essential to minimize the risk of exhaust system failures. 8873. Thrust reversers utilizing a pneumatic actuating system usually receive operating pressure from A. The engine air system. B. An onboard hydraulic or electrical-powered compressor. C. High-pressure air reservoirs. The correct answer is A. Thrust reversers utilizing a pneumatic actuating system usually receive operating pressure from the engine air system. In pneumatic thrust reverser systems, the actuation is achieved by using high-pressure air from the engine's compressor section. This compressed air is directed to the thrust reverser mechanism to deploy the reverser doors or other devices that redirect the exhaust gases forward, creating reverse thrust. The engine air system provides the necessary pneumatic power for actuating the thrust reversers. 8874. Operating thrust reversers at low ground speeds can sometimes cause A. Hot gas re-ingestion, compressor stalls, and sand or other foreign object ingestion. B. Abnormal exhaust gas temperature and engine pressure ratio indications. C. Engine vibrations. The correct answer is A. Operating thrust reversers at low ground speeds can sometimes cause hot gas re-ingestion, compressor stalls, and sand or other foreign object ingestion. When thrust reversers are deployed at low ground speeds, such as during taxiing or maneuvering on the ground, there is a risk of the exhaust gases being ingested back into the engine intake. This can disrupt the airflow and lead to compressor stalls, which can cause engine performance issues or even engine damage. Additionally, the reversed exhaust flow can stir up or ingest sand or other foreign objects, potentially causing damage to the engine components. 8875. Engines using cold stream, or both cold and hot stream reversing, include A. High bypass turbofans. B. Turbojets. C. Turbojets with afterburner. The correct answer is A. Engines using cold stream, or both cold and hot stream reversing, include high bypass turbofans. High bypass turbofan engines have a large fan at the front that bypasses a significant portion of the incoming air around the engine core. In these engines, thrust reversers can utilize the cold stream, bypass air, or a combination of cold and hot streams, exhaust gases, for reverse thrust generation. The cold stream reversing helps to minimize the risk of ingesting hot gases into the engine during reverse thrust operations.